Number 13, Amjad, and others who need to see it. So number 13, I give you this curve here. Y equals square root x squared minus r squared. It's not important to know the shape of this, because I tell you in the question. I actually tell you the shape of this graph is a semicircle, which means it looks like this. That's a semicircle. And what happens now is I rotate it to make a sphere. Very good. But I need to find out what those 2 points are. So any idea on how I could find those 2 points where it crosses the x-axis? Yeah, y equals 0. Which means x squared minus r squared needs to equal 0. The roots, yeah. Which means x squared equals r squared, which means x equals plus or minus r. Yeah, I don't need it, because I know to make it 0, then the inside needs to be 0.
Can you show me how the r becomes plus and minus? Because
really?
The square was cancelled and this.
Alright. Okay. You have 2 choices, Andy. You can either say it's like this.
Oh, yeah. Okay, I get it. Yeah.
So x equals plus or minus or you can use the formula a equals 1, b equals 0, c equals minus r squared. Either way, you get this answer from your quadratic, plus or minus r. Now, we use the formula for volume. Volume equals pi minus r to r, square root x squared minus r squared squared. Now, if I square this out, I get this. And now I integrate. So this will be x cubed over 3. And this one's actually minus r squared x, because the r is squared is like a constant, like 5, 6, whatever. I put in the 2 numbers, minus r and r. So that equals pi r cubed over 3 minus r cubed, when you put the r in. And then I put the minus r in. Minus r cubed over 3 plus r cubed. I'm just subbing these 2 in. So what will happen is this one will end up cancelling with this one, and you see you have 2 of these. Wait, hang on, I'm missing a number somewhere, sorry. Oh, they don't cancel. Minus, no they don't cancel, sorry. So r cubed over 3 minus r cubed. Wait a second. Alright. That's minus 2/3 r cubed. And then this one here, r cubed, that's 2/3 r cubed. Alright, I've done something backwards. I've gotten the right answer but the wrong sign. I got minus 4 over 3 pi r cubed. The answer should be 4 over 3 pi r cubed. How did I get it backwards? Oh wait, hang on. Did I write down x squared minus r squared, but the question was r squared minus x squared? The question said x squared minus r squared. I think that's backwards then. Yeah, r squared. The question should be r squared minus x squared. Is that what it is?
It's x squared.
No, so it's backwards. That's the problem. So in the question, The r squared and the x squared are the wrong way around.
So you should fix it.
The only thing that happens is, if you look here, you see here? Whoops, different colour. You see here? They get swapped around. So I'll just write they need to be swapped. And then you go all the way down to the bottom. So then at the very end, again, these need to be swapped, and then these need to be swapped. So that fixes the sign then. What?
Why RQ never cancel each other?
Why not? Why should they?
Minus RQ and another.
They didn't cancel. Well, why would they cancel? Why do you think they should cancel? Anyways, look, my point is, the sign was wrong at the end. That's only because I had it backwards in the question. And we know that this is the right answer, because if you look it up in a formula book or on the internet or your maths book, the volume of a sphere is 4 over 3 pi r cubed. And the physics student should remember that from physics. The volume of a sphere, 4 over 3 pi r cubed. You remember sphere?
Yes,
You know the
yes.
square again?
4 over 3 pi.
Yeah, so that's kind of like a proof of this formula. Okay. Mohammed, why are you sitting right in front of me, folding up pieces of paper, clearly telling me you're not... I mean, did you even write any of this down?
I was looking which one, like,
Give me that paper. Give me this paper. No, give me the reason why you're not writing this down. And make it good.
okay, I was checking the classes I missed because I've been kicked out and didn't remember because I've been late. So I was counting which page should I write it. So you were going down,
This is sounding terrible.
but I was counting the page so I can write.
Who cares? Just write it down and put the stuff you missed after it. Now you've missed everything I've been doing here. Because you were counting paper and folding up paper and tearing things out. What's wrong with you? Do you even want to be here doing the class right now, or would you prefer to go and I can mark you absent? Because that's what you're behaving like. No, so will you focus and write down what I'm writing down? Okay, let me zoom out a bit there. So like I said, here, these are the wrong way around. So you need to swap them. So that means here they're swapped, here they're swapped, here they're swapped, here they're swapped, here, no, as well. They're all swapped. It just means instead of the minus I get the plus. That's all. It's no big deal.
There's one question you said in the exam, you said it's very hard and nobody answered.
That was last class. It was the log x one. Yeah? I did that though, didn't I?
Yeah, I watched the video.
Oh, yeah.
I take one.
Yes.
Yeah, and you said that one is very difficult. It was D.
Yes.
and D.
Yes. And I also told you as well in class that nobody got it right in the exam.
Yeah,
So, but that's okay. If that's the only thing you don't get right in the exam, you're doing fine. Yeah. Alright, I need to go on now to the next topic unless there's something else from that worksheet. Was the problem that you didn't know how to do it, or that your answer didn't match the back?
the R.
The or was the problem. Right, okay. It's just a number. Like 5, whatever. Okay. Alright, next topic now. Proper partial fraction. So I'll take some of these as an example. Okay. So, as you might remember, if you want to add two fractions together, I won't write it down. Yeah, well, I'll do it. You know the formula, it's like this. But what's much more difficult to do is to go backwards. That is, if I have one fraction, to break it back down to the original two. It's actually much more difficult to do. So I'll give you an example. Like, for example, if I said 5 over x plus 1 plus 2 over x plus 2. You multiply the bottoms, so that would be x squared plus 3x plus 2, and then you do the cross here. You'd end up with this as the answer. So my point I'm making is, to go this way is easy. I mean, I skipped a step or two, but you can all do it. You just need to be patient and use the simple formula I gave you. What's difficult though is to go backwards.
So it's
Proper partial fractions now, yeah. That direction is quite hard. So let me give you some examples of how to do it. So let's start off with the first one there, actually. Minus 12 over 3x squared plus 8x plus 4. So this is my first example now. The first thing you need to do here, and it's actually okay if you want to use your calculator, is to find the two factors of that quadratic. And if you want to use your calculator to help you, that's fine. The first answer you get on your calculator is x equals minus 2. And then the second answer you should get on your calculator would be minus 2 over 3. Yeah? So that's 3x plus 2. Now, here's the idea. If I go back to my example up the top, how did I get this quadratic here? What did I do to get this quadratic?
Combining the denominators.
Yeah, I multiplied the two denominators here. And that's the same idea you have in your mind here. If I want to find the original two fractions, I start to think that maybe these two were the original two denominators. So I start off by thinking, okay, maybe this could equal a over x plus 2 plus b over 3x plus 2. This is the idea you have. That maybe your question could be written like this. Now, as it turns out, that actually is the right form it takes. But now the bigger question is, how do I find those two numbers a and b? In other words, how do I find a and b so that when I add these two fractions together, I get that bigger fraction on the left? There's two ways you can go about doing it. The easiest way, although this doesn't always work, it mostly works, is you multiply everything by this denominator. So, minus 12 times x plus 2, 3x plus 2, over 3x squared plus 8x plus 4. And then here, a over x plus 2 times x plus 2, 3x plus 2. That's a 2, sorry. Plus b times x plus 2, 3x plus 2. Over 3x plus 2. So what I did there was I multiplied those three terms by this. I put them onto everything. Can you see that? Yeah. And the reason for doing that is it simplifies it a lot, because both of these cancel the whole quadratic. Because don't forget that this is the same as that. It's just factorized. This cancels that one, and this one here cancels that one there. So in fact, after all of that, you're going to be left with this. 12 equals A, 3x plus 2, plus B times x plus 2. Okay, so like I said, there's two ways now to go ahead. Now the first method is the one I definitely recommend for the exam. It's the quickest one and it's the easiest one. Doesn't always work, but 95% of the time you should be fine with this method. What you do, I'll just recap slightly the situation we're in. Whoops. So remember, this is the question, okay? And we think we can write it as this plus this. That's what we think. So I simplified this a bit by multiplying everything by these two terms here. And now that has transformed into this here. It's a lot easier to deal with, right? And this is where the leap comes. If this is true, it must be true for all values of x. So for example, if I said x is 1, that must be true. You see the equal sign? I mean, the left is equal to the right. So what I'm saying here is, if I calculate this with x equals 1, what do I get? I get 12 over 3 plus 8 plus 4. Minus 12 over 3 plus 8 plus 4. Yep. Likewise, if I put 1 here, I get a over 3 plus b over 5. I don't know a and b, but they should be the same. The left should equal the right for all values of x. That's important, because when I get to this step, I can say, well, if this must be true for all values of x, then it must be true if x equals minus 2. Now, why did I choose minus 2? To cancel that one. So if this is true for all values of x, then it is true when x is equal to minus 2. So if I put in x equals minus 2, I can find the value of a that makes this true. So if I put in x equals minus 2, that's gone. 3 times minus 2 is minus 6, plus 2 is minus 4. So I get minus 12 and minus 4. So I bring the minus 4 underneath. Minus 12 over minus 4, 3. So then a must be 3. What would I do if I wanted to find b?
1.
Yeah, I'd have to put x equal to minus 2 over 3.
You could just use the a.
Or you could use the a and a different value of x, yeah. And that's a little bit easier, just cancelling this. But anyways, let me write that down. So first, I said x is minus 2, and I got a was 3. Okay? So what we say is, oops, it's true for all x, therefore it's true if x equals minus 2, therefore when I substitute that in there, I'll get a equal to 3. Now, if I do x equal to minus 2 over 3, that would give me b equals, let me see, so that's gone. 2 minus 2 over 3, that's 4 over 3. 4 over 3. So 12 times 3 is 36 divided by 4. I think it's 9. It is, sorry, minus 9. So what I did there was I put in x is minus 2 over 3 and I got out my answer, b is equal to minus 9. I'm skipping those steps because all you're doing is subbing it in and solving, okay? That's not a big thing, right?
You still have A.
No, I know a is 3 now. So I can carry that down into the next part too. So I can go back if I wanted to my original question and I can fill in now A and B. A is 3 and B is minus 9. So 3 and minus 9. And if you add these together, you do get this answer if you add these together. Okay? And to show you that, yep. So let me scroll down to, do you need me to write that down? Okay. What was the A? 3 over x plus 2 plus
minus 9.
Yep.
Over x plus
3x plus 2. So if I add these together, see, that's the original question, isn't it? Yeah, it is. Oh, but they didn't multiply the bottoms. But it is the original question. So you can see, if you add these, you do get this. That is was in the question, okay?
How can you check the defect?
You can't. You can't, unfortunately. Now, I said there's a second method to doing this. And maybe you might actually like the second method. The second method, what you do is you continue to open this up. So if I open this up, I get minus 12 equals 3ax plus 2a plus bx plus 2b. So I get minus 12 equals 3a plus b x plus 2a plus 2b. I just add this piece here together with this piece put in the front there. Or to be very, very clear, minus 12, you see what I did there? I put these two together here and took the x out. Minus 12 plus no x's equals 2a plus 2b plus 3a plus b x. Now, why do you think I wrote it very explicitly like that? Any ideas? Why did I open this up and just rewrite it down here like that? I mean, I'm not doing much. All I did was I put this at the back. Yeah? Compare. If you look at the left, number plus number x. If you look at the right, number plus number x. In fact, it is correct to say minus 12 must match 2a plus 2b, and 0 must match 3a plus b. So what happens then? You get two equations with two unknowns. What's the first equation? 2a plus 2b equals minus 12. And the second one, 3a plus b equals 0. And you know how to solve two equations, remember? In semester 1. And when you solve them, you get the exact same answers. Exactly the same answers when you solve these. So it's whichever method you prefer. This, of course, is quicker and easier. However, doesn't always work. It's important that you see this method too. Sometimes you might need to use this one. Okay? Yes. Second method always works. First method mostly works. Yeah?
I didn't understand how you get 0 based.
I didn't get it. I'm just making it very, 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 very clear that you have no x's on the left, agreed? So that's what I'm writing in here, that I have no x's. I have literally 0 x's. I have no x's on the left. So I didn't get it from anywhere. It's just me saying I have no x's on the left. It's like a statement. And then on the right, you see I have this many x's. But it must be that this is 0 to match its friend on the left. So you might call this a sort of comparison method. Whereas the one on the left, you might call it a substitution method. If you wanted to give them names.
So
Yeah.
we distribute, combine factor, and then we substitute to get.
I was talking about the first and the second.
Second.
Expand,
Yeah.
combine, and compare. Yeah. Although, of course, I skipped the last bit at the end, which is solving the two equations you make. But I mean, that's a simple task now for you. Yep.
Can you get a b equal to minus 9?
B equal to minus 9.
In the substitute.
Sorry, maybe I did it. X is minus 2 over 3. So if I put in minus 2 over 3, that's gone. That would be 4 over 3. Minus 12 divided by 4 over 3 is 9. Minus 9. Is it not?
Oh, I
Good. Andy? So it'll give me the same answer. I'll need to do a more difficult one now, but that's the basic idea. So for most questions, I will try to use method 1 as my method I will use. And I will only use method 2 if this fails. Okay? Yeah, how would you know it fails? Well, when we come to an example, you'll see how, okay? I mean, basically what happens is everything in the equation disappears and you can't find an answer for A or B. Usually too many things disappear. It works nice here because I can make this disappear and keep this, or vice versa. But we'll see that. We'll see when we come across it, okay? So let's have a look at another example. So let's say minus 22x plus 62 over 45x squared minus 19x minus 42. I'm going to write that again, that's a bit messy. Okay. 45x squared minus 19x minus 42. Okay, so the first thing we need to do is find the factors in the bottom there. So, Amjad, if you type this in on your calculator, what two answers do you get? Just give me the answer you get on the calculator. 6 over 5, so that'd be 5x minus 6. And the other one?
Minus 7 over 9.
Minus 7 over 9. 9x plus 7. Okay. Oh, by the way, Mal, you figured this out. The name of these are called proper partial fractions. I don't know if I said that at the start. Anyways, what we do next is the same as before. I'll multiply everything by these two. Oh, well, sorry. Before I do that, I have to... can anybody tell me the verb, actually, for what I'm doing here? If I'm saying I think that this is equal to A over 5x minus 6 plus B over 9x plus 7. Can anybody give me a verb that describes what I'm doing there? No, I mean more the general idea. It's true I'm separating, but more the general idea. Huh? No, think more English, less maths. More technical than guessing. You're right, it's a type of guessing, but... yeah, hypothesizing? Do you know this word? Hypothesis? What about supposing? Supposing? So I'm supposing the answer to be this. Or I'm suggesting that the answer is this. Do you understand this word, yeah? Or, you don't know this word? Hypothesis? No? Alright. Suggesting or supposing.
Is it assume?
Or assuming, yeah. Okay, so if you remember, what I do next is I multiply everything by these two here. So just to save space, I'll just draw in 2 brackets that represent these two. So you'd have bracket, 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 bracket. And what happens, what always happens, every time, is these two cancel that. Then first one will cancel the first one here, and then the second one cancels the second. So what you're left with here will be this one, and what you're left with here will be that one. What's wrong, Andy?
Why don't we just keep this part?
Why don't we keep what part?
I mean, why don't we just keep this? Can I just skip this and just get like minus 22x plus 6 equal to
No.
3 plus 1 of the
Short answer, no. I want to see this step. 5x minus 6. Who's that coming in now? Is it already that time?
I want to come later and tell him.
All right. Okay. So I'll use the first method now. So if I use the first method, what do you think I should let x equal to? Suppose I want to cancel this.
Plus 6 plus 5.
Yeah, 6 over 5. And I substitute that in, and I get, therefore, a equals, so I need a calculator here, minus 22 times 6 over 5 plus 62 divided by 5, divided by 9 times 6 over 5. So after doing all of that, I'll end up getting a equals 2. Now next, what should I let x equal to? I think I should let it equal to minus 7 over 9. What's wrong? I don't think it's easier. Yeah.
Just let it equal to 1. You get a number.
Yeah, but then I have more numbers.
You could just divide them.
It's easier, but it's slightly longer. Okay, so if I let x equal minus 7 over 9, this goes, and I'll be left with getting b equals, let's see, minus 22 and minus 7 over 9 plus 62 divided by 5 times minus 7 over 9. Minus 7 over 9. Okay, and then that middle one's gone. Divide by 5 times minus 7 over 9. Minus 6. So after doing that, I'll end up getting b is minus 8. So now I have my answer. I can say minus 22x plus 62 over 45x squared minus 10x plus 25 equals a, which is 2, over 5x minus 6 plus b, which is minus 8 over 9x plus 7. So I've now separated them into 2. Get those couple at the back there. Yeah, that's fine, just to help a little bit. No, you can leave the window open, Andy. What's wrong? Where? Oh, sorry, I just wrote it down. Yeah, sorry. Minus 19x minus 42. Yep. And the reason for, well, what do you think the reason might be for writing this into these separate two here? What do you think might be the reason for doing this?
The denominator x squared.
Yeah, but no, what's the reason for splitting it like so? Yeah, well, think about the chapter you're on. What chapter are you on? Integration. This is very difficult. In fact, almost impossible for you to integrate. But this one, you've seen how to integrate. How do you integrate this? This was in the section simple rational function. So what do you do here? Yeah, and then this one is the same. So integrating this, extremely difficult. Integrating this, not so bad. Okay? This is a section B question in the exam. Well, not quite this one. In the exam they usually end up giving you 3. Okay, I think we might get that done now. Yep. Don't worry, we're getting to that now. We're moving up. So the next one I'm going to do, so I'm going to skip a few because they kind of have a similar idea. But skip down to G possibly. Yeah, G. So in G you have 142x squared minus 143x minus 37 all over 56x cubed minus 66x squared minus 227x plus 105. What one did I say this was? F, was it? Or G? G. Yeah. Now this is more like what you get for the exam. Wait. Listen. A bit of vocabulary. This is called partial fraction. But the word improper and proper, I should clarify it now at this point. We call this proper partial fraction because the numerator has a smaller power than the denominator. Okay? So you need to make note of that. That's called proper partial fraction. If the numerator is a power lower than, or we might say an order lower or a degree lower than the denominator. Yeah, that's the word proper in proper partial fraction. That's what it means. That the power here is smaller than the power here. And I said smaller, not equal, must be smaller. And B?
Yeah.
Did you write that down?
I never see.
But what do you think will make me happy right now? Thank you. Mohammed, did you write that down? Nah, can't see that. Proper, lower power. Could have written a bit more than that. It's fine. Proper means the numerator has a smaller power than the denominator.
Yeah, so what's it called? Proper.
Proper. The name of the lesson if you open the right page.
So does it have to be relatively lower or just
No, that's a good point. Anything smaller. It doesn't have to be 1 degree. Numerator, denominator, come on. Now, we can take out our calculators and we can use mode 54 for the cubic. Because this question is not testing your knowledge of solving cubics, it's just testing your knowledge of the fractions. So mod 54, A is 56, B is minus 66, that's minus 227, and then 105. Alright, so let's get down the first answer. A, well, I won't skip any steps. Yeah, I got here, hang on. 4x plus 7. That's my first answer, yeah? 2x minus 5, 7x minus 3. Did you get the same? No. 56 minus 66 minus 227, 105. 56 minus... yes. Alright, 142x squared minus 143x minus 37. Okay. Bar here? Oh, for this one? Oh, you could. But I really think it's not going to help actually, because what you really want to know is what's the form of the denominator. I mean, you could, but I don't think it will help anything. Yeah, I don't even think it will have... I don't even know if it will have factors. You can check, but I don't think it will help. So, next we suppose that this is equal to A over 4x plus 7 plus B over 2x minus 5 plus C over 7x minus 3. No space, plus 105. Now we use our same trick of multiplying. So to save space, I'll just put in 3 brackets. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then 1, 2, 3. So likewise, all those 3 will cancel all of that. The first one cancels the first one. The second one cancels the second one. And the third one cancels the third one. Just like before. So I'll be left with this. 142x squared minus 143x minus 37 equals A, 2x minus 5, 7x minus 3, plus B, 4x plus 7, that's 4x plus 7, 7x minus 3, running out of space, plus C, 4x plus 7, 2x minus 5. It's gone too small now, I think. This is a minus, a plus, and if you can't, well, you know what they are because they're the same as the original here. Okay, what do you think I should let x equal to first? Yeah, well, it depends which one we want, but if I said let x equal to 5 over 2, what would happen to this one? Cancels. This one stays, and this one cancels. So if you let x equal 5 over 2, you get B. Now if I let x equal to what next? Say 3 over 7, goes, and I get C. And then finally, if I let x equal to, most of the last one there, minus 7 over 4, cancels, and this gives me, get A. Yeah. Which one?
B.
Here. This is 4x plus 7 times 7x minus 3. So then you get your BCA and you're finished again. I won't bother doing the last step.
How many marks per exam for this question?
It's pretty big actually. It's like maybe 5 or 6 marks. It's pretty big. It takes a little bit of time to do, you know. But this isn't even an exam one yet. I'm getting to exam difficulty shortly. In fact, maybe the next one. Let's see. Yes, the next 2 examples, I think, will be more like exam questions.
What's the question? B2 or B?
Section B. Now these ones, like this would be maybe, well maybe not this one, but something like this, that'd be section A question, with just 2 of them, like this, okay? This isn't quite section B, the next one I'm going to do now would be a section B.
Which question will be?
It's in section A and B. For example, question A here in the book would be section A, whereas the one I'm going to do now, is it I I'm doing next? No, sorry, H. H and I. H and I, for example, would be section B type questions.
B3.
B3 or 4. Actually, yeah, you could probably see it there. Okay, next now. What? Huh?
B4 is vector.
Yes.
B3.
Now, the next one. I'll do a couple more. I know they're difficult. Now, what did I just... H, isn't it? Okay, so H here. 16x squared plus 65x plus 18 over 28x cubed plus 36x squared plus 15x plus 2. Okay, Amjad, no, I have the calculator here. So let's see what we get here for our cubic. 28, 36, 15 and 2. Sorry, that looks like a 12, doesn't it? It's a 2.
Minus 12.
Sorry, am I writing down the... No, it's plus 2. So the first one would be 7x plus 2. The second one would be 2x plus 1. But you notice now the calculator stopped. Now this is why this is more difficult. If you look at the calculator here, it only gives you these 2 answers. But I absolutely know for certain there should be 3 answers because it's cubic. So what has happened? Why is the calculator only giving me 2 answers? Where's my missing answer? 1 is repeated, yeah. One of these answers must happen twice. That's why the calculator didn't give it to me again. So now we need to figure out which one is repeated. So wait. We can figure it out by looking at the 2 possibilities. So the first possibility, suppose this is repeated, okay? If this is squared, after I open it up, I don't care about all the numbers, but after I open it up, the number at the very end will be 4. Why will it be 4? Because of the 2 squared at the end, you know, when I open it. And that's too big. But if I put the square here, after I open it, it's 1 squared, which is 1. And if I multiply that by 2, I get the 2 I need, okay? So you don't need to put the square here and check which answer matches. You can just do what I like to do, which is by checking the backs. checking how to make the backs match up. This is something similar we did in semester 1. I'm not sure if you remembered this. It was a little trick I showed you. Do you remember the one I'm talking about? So we can check the backs to see how to make them match up. So we know the square must be on this one. Okay? Yep.
Can we do the first one?
Do-
Can we use the 28?
Can we use what?
28 is like more easy.
What do you mean use 28? What?
28.
Oh! Yeah, if you like. The fronts or the backs. I always use the backs. It's just my choice. Okay. Can I go ahead?
If I just write a square is better, or if I put another bracket?
Square, please. Now, this one here is quite different to all the other examples I did. It doesn't seem like the square should matter much, but it actually does matter a lot. So just, I'll just write here dot 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 for this left side here, okay? Equals. So I have a over 7x plus 2. That's, I think, fine. But what do we think for the next piece? Yeah, b over 2x plus 1. But this is the problem. There's only 2 brackets here. If I add these together, the denominator will be a quadratic, not a cubic. So I still need something else. C over 2x plus 1, it's actually going to be squared. So these are the 3 you use. But in fact, that's actually wrong here. Now, I'll talk more about that now. What's that, Andrew?
Why square? Do we have two?
What is the square?
Why wouldn't it? You see, I'm getting up to explain this. Yep. Suppose I didn't have this. So this last piece here is gone. Okay? If I add these together, what type of denominator do I get? A quadratic, because this multiplies this. Yep. But what type do I need? Cubic. Now, suppose I didn't have 2x plus 1 here. Suppose I had something different, like 5x plus 9, 10x plus 100, something else, okay? If I add these together, what do I get in the denominator? Cubic, don't I? And what would be the 3 terms? It'd be this one, it'd be this one here, and it'd be this one here that I just made up. So, you can't put anything here. What goes here can only be things that are present here. I've used this one here. I've used this one here. Andy suggested writing this as 2 brackets, yeah? So then if I use the 3rd one here, it'd be exactly the same as this, wouldn't it? Because it'd be the same denominator. Yeah. So the only possibility left that I've not used to make 3 fractions, because I know it must be 3, is by using this squared. It's the only choice left. That's why I pick it, because I can't pick anything else. Yeah, one at a time, so yeah.
I didn't understand. They asked you why did you put square.
Yeah, yeah.
I didn't.
Okay. You're,
If we multiply it, it wouldn't be cubic.
yes, I get what you're saying, because if you put this here, here, and here, and multiply together, it wouldn't be cubic, it'd be x power 4. Or would it? Because let me tell you, it would actually be cubic. But let me show you why, okay? So what I'm going to write down is, you don't have to write it down, but it's a little note to explain, well, you write it down if you feel you need to, but it's a little note to explain why this would be cubic, okay? Now, I left this blank for the moment, yes?
No, we put b plus c over 2.
Yes, I'm getting to that in a minute.
Can we do this?
If you prove it, it's gonna be cubic, and then not. But if we don't have the square, it's still cubic, right?
Yes.
No, if we don't have the square here, if we have it like this, it'd be quadratic. Because look, these 2 are the same, aren't they?
Yeah.
So they go together to form 1. Like imagine I had 2 over 6 plus 1 over 6. What do I get? 3 over 6. If the denominators are the same, then they merge together to become 1. So I can't have it like this. This is to make it to have 3. But Abdal said, and Andy said too, which is a true point, this won't be cubic because it'll be this multiply this multiply this. And what type is this? Quadratic. So it'll be quadratic multiply linear multiply linear. Well, yeah, forbic, yeah. That's not actually the right word, but you have the idea. Well, let me show you. I'll use a different colour. For the moment, let me just put C in here. Okay. So if I want to add these together, now you don't have to write this down, this is just to convince you that it's cubic. I could change this into A over 7x plus 2. Now if I multiply the top and bottom by 7x plus 2, I get 7x plus 2. And then I multiply the top and bottom by 2x plus 1 and 2x plus 1. Now I do the same thing here. I multiply the top and the bottom by 7x plus 2, 7x plus 2, and then here 2x plus 1, 2x plus 1. And then for the last one, I multiply the top and bottom by 7x plus 2. 7x plus 2. Now if you look at my denominators, this is 7x plus 2, 7x plus 2, so that's 7x plus 2 squared times 2x plus 1, dot, 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 plus, and then here it'd be the same thing, 7x plus 2, oh sorry, I put the wrong one there, that should have been 7x plus 2. Anyways, you get what I'm saying. You can see the idea. I'm going to make the 3 denominators the same. You see? They're all the same now. What type of denominator is this? Cubic. And what type is this? Cubic. And what type is this? Cubic. And they'll all go together to have 1 cubic as the denominator, which will be, there it is there, 7x plus 2 squared times 2x plus 1. In other words, I'm showing you here that you can combine these 3 here and get a cubic in the denominator. Now you might say, what happens if I use that rule I showed you at the start? Remember the one where you do the cross? And then you do the cross here? If you did that rule, you'd still get a cubic in the denominator. Because what will happen, I guarantee it, is something on the top will cancel something in the bottom to change it down to cubic. Guaranteed. Okay, so the long story short, this will definitely make a cubic in the denominator, definitely. Okay, now before I go ahead, just make sure we're all clear with that. Come on. Oh, this is as far as I can undo, it seems. Okay, back to this now. So, Abdel, Andy, you're happy that this will go together to make a cubic in the denominator? Happy enough? Yeah. Now, I left this blank here, and I left it blank on purpose. It's tempting to put C up the top here, because it seems like previously those were the rules I was using, wasn't it? You have A over something plus B over something plus C over something, right? But to be very, very, very clear, that's not really the rule. The rule is more precisely this. You always put something on the top that is 1 lower than the bottom. So for example, if this is linear, what's before linear? A constant. If it's a quadratic, what's before a quadratic? Linear. And what's before a cubic? Quadratic. So this is linear, so it gets a constant on the top. This is linear, so it gets a constant. And this is quadratic, so up the top here is actually a linear. So it's not C, it's actually this. Cx plus D. And that's the general rule when you're breaking this up. And you should note that. that its numerator needs to be a power lower than the denominator when you separate it.
Must be.
It must be. Now, well, it can be a power or more. So, for example, it might turn out later that maybe the C is 0, which is okay. I'm just saying the most general form you can make is like this. 1 power lower than its denominator, okay? So here it's cx plus d, because this is actually a quadratic. Now this is kind of a strange quadratic, because it has 2 roots, but it's still a quadratic.
Yes.
Okay. Right, so now we'll go ahead and see what answer we get. Okay, so you've noticed on the left I just left dot 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 there. But you know what I do next? What do I do next? I multiply by the 3 factors. So you get the idea. What's going to happen is, what happens to this denominator here? It cancels. So I'll just be left with 16x squared plus 65x plus 18. And then plus 18. This will cancel one of the factors, leaving me how many? 2. So I'll be left with a times 2x plus 1 squared plus b times 7x plus 2, 2x plus 1, plus c times 7x plus 2. Yep.
Shouldn't the one to the AB cube?
No, that's right, I think.
Because the 7x plus 2 cancels, but 2x plus 1 and 2x plus 1 squared remain.
Yeah.
So when you multiply them, it's 2x plus 1 cube.
Where are you getting the third one from?
Because you multiply by the 3.
You need to imagine 3 brackets here, yeah? So the first one cancels that, and it leaves you with these 2.
This one and 2x plus 1.
No. Just when I say these 2, I mean this twice, or this with the square. I think you're thinking of this, and this again as a square. No, not that. It's just 3. In other words, this thing. It's always the denominator, okay? So I'm using this denominator to go onto all of them.
So we are not using the second line with the
This one?
all of them. We are not using these 3. Right?
No, you're right. Okay, good point. Right. You're using this denominator always. Yes. So I'm putting that onto the 3 of them. So when I put this one here, what happens? You can imagine the square one cancels that, and I'm left with 7x plus 2.
How are we going to finish this chapter?
It needs to be a double cross. This one.
Integration is long.
Huh?
Integration.
I know, it's difficult. Now, look up here. Now we need to choose our values of x. So what my first one would be? I'm sorry, I left out my c. That should be cx plus d at the end here. Let me just write that in again. Cx plus d. I need to scoot over. Times 7x plus 2. Yeah. Alright. So, yeah, what's that I've done? Let x equal minus 2 over 7. Good, what will that give me? I'll get A. Good. Okay, what's next now? Let x equal minus 1 over 2. So that one goes, and doesn't quite give me, doesn't quite give me C or D, because I'm still left with C or D, aren't I? So like,
CX plus D.
yeah, I get something with C and D in it, so that's not great. So maybe there's something else we can try.
Minus 2 over minus 11.
Isn't that what I just had?
Just have it.
Yeah.
Cancels B and
But you have C.
You see that? Now this is Amjad, we saw earlier. This is the problem, Because if I say let x equal to, like we see here, minus a half, I don't get anything. I'm left with C and D. You see, this will go, but I'm still left with a C and a D. Do you see the problem? I have two. Now, is there any other choices I could make?
Method 2.
Yeah, method 2. So first, did you write that long expression down? Yeah? Because I need to type it in.
No.
Hold on, Andy, I know what's going to happen, okay?
No, I'm just right.
Alright, okay.
One no.
Yes, method 1 not working, it's broken. Okay. So can you tell me what did I have on the right here? 16x squared plus 65x. Wait, hang on, this is the left, isn't it? Alright, go ahead, plus 18. Okay. Whoops. Alright, what did I have on the right then? A 2x plus 1 squared plus B 7x plus 2, yeah. Right, just 7x plus 2?
Times.
Oh, yeah.
2x plus 1.
Okay, plus C x plus D 7x plus 2, isn't it?
Yes.
Alright, so what do we do in this method? We expand it. Simplify, expand, and you get this long thing here. Now I'm not going to expand it, because you know how to expand it. You know how to open this from semester 1, don't you?
Yes.
You know how to multiply these, don't you?
Yes.
And you know how to multiply these?
Yes.
So you expand it, and then you group them together. So there's all the x squareds, all the x's, and then the numbers at the end. Now in the second method, what do you do next? Compare. So I say 4a plus 14b plus 7c equals 16. And then this one here
65.
equals 65. And these three here?
18.
18. So I make three equations with three unknowns. Now, huh?
Where's A and B come from?
What? This?
A and B is.
What are you talking about, Amjad? There it is right there. I just wrote this out.
Oh, okay.
Right. So my first equation, 4a plus 14b plus 7c equals 16. Very good. And the next one, 4a plus 11b plus 2c plus 7d equals 65. And then my last one, a plus 2b plus 2d equals 18. Now, I think you might have spotted something. I actually said there's three unknowns, but when you think about it, there's not three unknowns. How many unknowns are there? There's four unknowns. There's four unknowns, but how many equations do I have? Three. So if I ask Derive to solve this, it should say no answer. Because it needs four equations, and I have only three equations. Why did that happen? Well, if you recall earlier, I said this one here, although it's a quadratic, is a little bit strange. In fact, there is a fourth equation. When I told you it's cx plus d, it actually turns out that one of those will be 0. The problem is, I don't know which one. I know it'll be linear, so it's cx plus d. But it's actually a special type of linear. It'll be just cx or just d. I don't know which of the two it is. In the exam, they will tell you. But I don't know right now. So what I have to do is look at both possibilities. So possibility number 1 is if c equals 0. Let's try and solve it. Solve system, 4 equations, 4 unknowns. line 4, 5, 6 and 7. Solve. And I get my answers. But I don't think this is, this is a B, and you can see C and D. What was my second choice? My second choice, I said maybe D could be 0. So if I try this now, solve, system, same deal, 4 equations, number 4, 5, 6 and 7, and you see I get this answer. You see how I get two different answers? The first one, well, the A is the same for both. A is 4 for both. In the first case, B was 0, B is 7. C is 0, C is minus 14. D is 7, D is 0. So I get two possible answers. Okay? Which one do you choose? Well, you shouldn't get this situation in the exam. In this exam, they will tell you which of the two it will be. You can see it in the question. So I don't think you have the, is somebody have the revision papers there? Yeah, we'll take one as an example, okay? So if I look at this one for example, where is it? I don't think it's in this here. Alright, different one as an example. Which one, Andy?
Page 8, version 1, 11, 12.
Sorry, I've messed these up.
Page 8? Yes.
Page 8? Oh, so we need to go near the front. There we go. So if I was looking at this one in the exam, I can see that it has A, Bx, and C. So I could see they're telling me the answer should look like this. So they're basically telling me here that this piece here, the Bx, it has no constant on it.
It's not really.
Yeah. You like here. Do you see here? What they had in the answer was only this. Okay. They said in the question, this here can be written as a partial fraction that looks like this. Except they didn't write in the D. So that means I know the D is 0. Okay? If they didn't tell you that, then you actually have two possible answers, at least. The C is 0 or the D is 0. It takes a long time, I know. But remember, I promised you semester 2 was more difficult, and I wasn't lying. Didn't I promise you? And I wasn't lying, was I? No, it is more difficult, isn't it? Yes.
So how many marks would this be?
Well, see, this would be a big question. There's still a second part to this. But like, for example, in this one here, it's 4 marks for finding the ABC, and it's 6 marks for doing the integration. So this topic, when we finish it, it'll be a 10-mark question in the exam. So like number 3 here in the exam, number 3 is the integration chapter. So for example, part A is the integration by parts, we did recently, and then the part B, part 1, is what we're doing today, and then in a few classes we'll do B part 2. Yes, it only gets more difficult as you go down.
Which section B, which question?
Number 3. Now,
So normally people skip this bit.
no, it's not as bad as you think. Okay, hey, stop moving. Listen to me. It's not as bad as you think. This is page 38 as an example. Oh, you need to get it out. Okay. Now I still have to do another example. So I'll just stop that one there now because we have the ABCD, which is the goal. We're trying to get the ABCD.
Can we jump down to this?
Yes.
Can we do the other question this one?
That's what I'm going to do. Yes.
The answer not derived.
From this. Yeah.
The answer not derived. The answer is
Yes. It's going to be, well, which one did I go with at the back? Let's see. I think I went with making this, which letter is this H? Yeah, so my answer at the back, if you look, I make the C 0. Of course, I should have told you that in the question. So if you want, hey, listen, for this worksheet for today, whenever you come across this situation here, okay, I think I always went for making the C0, okay? But it's not always like that. I just did it like that for today. Okay? It could have been the D is 0. It's the same in the question. I'll make note of that. I think I left the C 0 because for the first lesson on this, I think I was originally thinking people will just do A, B, and another number here. So that's why I put this one 0. So it looks the same as these two. You get what I'm saying? That is constant linear, constant quadratic. But all I want you to know is, in fact, it should really be linear quadratic. This is the general rule. Now I have to still do another example of this, yes?
They didn't do,
But that's a different question which I'm going to do now. Different type. Yes?
On drive, you made D equal to 0.
I did both possibilities.
So you substitute D with each.
Yes, yeah, like this, yeah.
But, I mean, how can we...
No, I substituted C as 0 actually. One of these needs to be 0. I made C 0.
In this quadratic?
Yeah.
Or in the...
In the equations.
In these equations?
Yes.
But if I made it 0, I mean, theirs will be the other...
Oh, exactly. So you still have to solve it like how you did semester 1, using the elimination method. Which will take some time. Okay, next example now. Okay, next one now. I 6x squared plus 15x plus 45 over minus 3x cubed minus 13x squared minus 28x minus 8 equals. Sorry, it's in a different colour. Alright, well, like before, what's our first step? Factor. So mod 54 minus 3 minus 13 minus 28 minus 8. So if I type this in, on the top, on the top, I'd get the same, 6x squared plus 15x plus 45. And then on the bottom, I'd get 3x plus 1. And now, I don't get the other answers. So what's happened now?
Repeated.
No, not repeated. Oh yeah, I get what you're saying. This is repeated 3 times. But it's not going to be that. Good guess though, because if I have 1 cubed, what would I have at the back?
3.
1 cubed? 1, which doesn't match up here. So good guess, not repeated 3 times though. Yeah. What will happen is, this other piece here is a quadratic, but it's a quadratic with no roots, no factors. Yes. This is a quadratic here with no roots. If you remember when we did our chapter on cubics, we can have a cubic with 1 root, 2 roots, or 3 roots. My first example, yes, we need to divide, very good. My first example was 3 roots. Then my second example was 2 roots. Now this one here is 1 root. And as you said, to find the quadratic here, what I need to do is long division. So I need to take this cubic and divide it by this linear, and I'll get the missing quadratic here. This is what we did when we did our long division on cubics in semester 1. So to find this quadratic factor here, because remember, just think about it. You have your cubic, and you have 1 factor. And how do you find the other factors? The long division, remember? So it's the same thing. I have my cubic, I have 1 factor, and I want my other factor. So, same deal, long division. So I'll take this and divide it by this one. Yep? No, this is the only way it can be done.
Maybe,
So, long division now.
maybe this is cubic, but the other one is just linear.
No, the other one will have to be quadratic.
But I mean, now we're dividing them.
Yep,
I mean, maybe this one is quadratic,
yep.
no, I mean cubic, no,
Yeah.
that'd be quadratic, and the other one is linear.
Square.
I mean, now we said it's not cubic because it's 8, but maybe it's quadratic, and the other one is gonna be the.
I don't know what you're saying.
He's saying what if 3x plus 1 squared, and the other thing was...
Oh, yes, yeah. Of course, this is a possibility, yeah. But my method of line division would also give that out as an answer if it was the case, yes. So you're right, you're right. It could be the case that this is quadratic, but I don't think so. Because if this was quadratic, then what would be here? Linear. And my calculator would give me that answer if there was another linear one here. Because it didn't, I really don't think it's a linear here. I think it can only be a quadratic. Yeah. So let's do the line division and see what we get. What? I'm sorry, Amjad. Look, it won't take that long. We can do these quickly now. Minus 3x cubed minus 13x squared minus 28x minus 8. Okay, so yeah, that's the first one will be x minus x squared. So I get minus 3x cubed minus x squared. If I subtract, I get minus 12x squared minus 28x minus 8. So up here should be minus 4x minus 12x squared minus 4x. I subtract minus 24x minus 8. So to finish, minus 8. Yes. So that quadratic goes in here now. Minus x squared minus 4x minus 8.
If it was remainder.
Oh dear. If there's a remainder, there's a big problem. It's probably your mistake.
So it can't be.
Not for this lesson, not for today, no. Next lesson.
If
Yes.
there is a remainder, which means that is not the 3x plus 1 was in the answer.
Yeah, which shouldn't be the case because the calculator gave you that answer, so it means it's your mistake. Okay, I need to remove this long division to make space. You got the long division? Well, actually, no, I don't. You know how to do long division, so you can do this yourself if you need to.
I don't know why you're talking because.
Yeah, I don't know. You do know how to do long division from semester 1. I think you were quite good at it. So I don't need that there. So I got that one from long division. Now I need to write in the A's, the B's, the C's. So I suppose the answer will equal, so what do we think now? A over 3x plus 1 plus, now, yeah, bx plus c over minus x squared minus 4x minus 8. Very good. And I'll just write same here, just to save space and time. Yeah, just the same thing goes down. Yeah.
C equals 0.
No! The problem only happened last time because I had 4 of them. I had A, B, C, D. But how many do I have here? 3 of them, A, B, C. So I don't need to make any of them 0. I have enough. I don't have too much. Do you understand? Because what type of equation is the denominator? It's cubic. Which means usually I can make 3 equations when I do my comparison. You know? And I have 3 unknowns, A, B, C. So it should be okay. Now maybe, Amjad, maybe it won't be. Maybe I'll have the same problem. If I do, then what happens? The B is 0 or the C is 0. We don't know. We'll have to see what happens. So I do my multiplication next, and I get 6x squared plus 15x plus 45. You know I put the brackets in. Equals A minus x squared minus 4x minus 8 plus bx plus c times, sorry, hang on, I put my brackets in to help me out here. So I have two brackets and then they cancel. I have two brackets and then the first cancels the first. Then I have my two brackets, the second cancels the second. Okay, so I'm left with here plus bx plus c times 3x plus 1. Alright, let's multiply this out on the right. So on the right, I'll end up with minus a plus 3b x squared plus minus 4a plus 3c plus b x. We could, but I have a funny feeling that it's just not going to work, so I'm just going to go straight into method 2. But you're right, you can give it a try. It'd be great if it does work. I don't think it will, though. Hold on. Let me just write down this one here. Minus 8a plus c. Yeah, how did I get this? How did I get this answer here? Well, what I did was I multiplied a in here, then I multiplied these two, and I put them together. So, for example, minus x squared times a, minus ax squared. An example here, bx times 3x, 3bx squared. So you see, that's 3bx squared. And you see here, that's minus a because of the one here. So I know I skipped the line, but all I did was I multiplied and then I grouped together. So there's all the squares, all the x's, and then this is the numbers at the back. Example, minus 8 times a, minus 8a. And then c times 1. Okay. What's wrong?
No, I showed him that he could use.
Can I go on? So now I make my three equations. So what's my first equation? Minus a plus 3b equals 6. And then minus 4a plus 3c plus b equals 15. Good. And then my last one, just listen. Minus 8a plus c equals 45. What's wrong, guys? Ask me, please. What's wrong? What's wrong, Andy?
You say the method 1 can be used.
If it can be, that's great. That's great.
No, he's saying it can't be.
I think it can't be.
But we put first x.
If I put x is minus 1 over 3,
You'll get
that's I get the a. Great.
Then x is 0. You can get c.
No, if I put x is 0, oh yeah, I could get this. Wait. I could get the c, couldn't I? Yeah.
And then you use x is 1. You get b.
If you x is 1, f is 0, you can get a and c in the same time.
But you have a in the previous one. You're right. No,
With a different x, how can you get a c?
hang on. Listen. If you want to use the first method, that's fine. Just listen carefully. I did not use the first method because I much prefer use the first method when I can cancel things nicely with the 0, making the zeros. Your way of doing it will work fine, but I just feel it's a little messy, but it'll work fine. So what you're suggesting, Andy, what he's suggesting, is first you make x equals minus 1 over 3. That will go, and you got the a. And that's it, you have the a. Then what he said to do next is you make x 0. This will go, you'd be left with a c here, but you know the a from previous. And then to finish, you make x equal to any number you want, like x is 1. You'd be left with an ABC, but that's fine because you have the A known, you have the B known, and then you can solve for C. But I don't like it that way because I feel it's a bit messy. So that's why I'm doing the second method here. I think it's a little neater. but you'll get the same answer. Okay? I much prefer method 1 when you have nice 3 things you can cancel one at a time. Otherwise, I use method 2. We'll call this method 1.5 because it actually is somewhere in between the two. But this is difficult enough without me complicating it further. Okay? Now, what techniques should you use to solve these 3 equations here at the end? I think Abdal's right. I think substitution might be the best one here. Because what you can do is, you can get the C here. So what would C equal? 45 plus 8a. And then you can put that in here. And you can put it, there's none there. You can put it in here. So what letters would I have now if I replace the C here? What would be in this one? A and B. And what's in this one here? A and B. So then it's just 2, like you've learned in semester 1. So what you would do to finish this, you would say C equals 45 plus 8a, and you put that in there. So then you'd get minus a plus 3b equals 6, and then you get here minus 4a plus 3c, which is 45 plus 8a, plus b equals 15. Now you can use any technique to solve these 2. First, of course, we'll have to clean this up, right? To clean it up. So, how many a's do I have? Well, 8 times 3 is 24. You see here? 24a. 24a minus 4a? 20a. So that's going to be actually here. I'll write it above it here. That's the first equation. Then the second one. 20a. Now, how many numbers? 3 times 45 is 135. 135 minus... Oh, sorry, I should do the b's next. How many b's? Just b. Okay. And then 135, I bring it to the other side, becomes minus 135. 15 minus 135 is minus 120. Now, how many equations have we left now? 2. And how many unknowns? 2. And you can use any method now to finish it. So what would be a quick method way? I think if we multiply this by 3, then what could I do? If I multiply this by 3, what would I get? What would happen? I get 3b here. Why would I want 3b? To eliminate that one. So if I eliminate the b's, I'll get then a. Once I have the a, how do I get the b? Sub it back in to here. Then I got the b. Once I have the a and the b, I can put it back into here. I got the c. Huh? No. You know this is not what I want. What I want is teacher, I don't understand here to here.
Yeah, the next steps like this.
Yeah, very fast.
I know. But remember, I've just spent 2 lessons on one topic. Right, Amjad. I want to give you some independence. I'll finish it. Right, so what I do to finish is I multiply this one by 3. So I get 60a plus 3b equals minus 360. And here minus a plus 3b equals 6. Now what happens here? The b's go, yes? And I get a. After I get the a, what do? Put it back into here and I get the b. Once I have the a and the b, I can put it back into here, get the c. And then I'm finished, because that's what I'm looking for, the a, b and the c. It's difficult to be calm with this class. Now look.